Welcome to part 3 of the head gasket repair tutorial on this 1988 Porsche 944, where we'll be wrapping things up and getting the car back on the road. In summary from part 2, the engine was rebuilt after the service work performed on the cylinder head and the head gasket replacement and all the other seals on the top of the engine. The engine did start, but there was a misfire on cylinder number 2 due to a clogged injector, and the injectors were sent back for a warranty cleaning and have now returned. And it was confirmed that the injector on number 2 was stuck in a closed position, but there were no electrical issues. It was just clogged with some debris and is now cleaned up and ready to go. So I'm going to go ahead and reinstall the fuel injectors, pressurize the fuel rail, complete another couple heat cycles on the car to vent the coolant system, and then we'll perform a compression test to assess the overall health of the engine and take it out on a test drive and close out this repair. Here are the fuel injectors ready to be installed. These just arrived in the mail about an hour ago, and the calibration report indicates that one of the injectors was closed, as I had suspected. The guys at RC were super responsive and helpful, got them turned around in 24 hours, and I don't even think it was anything that they had done in the first place. Probably just some debris in the fuel rail, and these things are really old and sensitive, so I'm confident they'll be good to go this time around. So we'll get those popped onto the rail, coat the O-rings with some ATF. In doing so, reroute the spark plug cables while we're bolting it down, reconnect the 2 vacuum lines, and pressurize it, and then we're good to go. With the injectors and rail reinstalled, I reconnected the battery, removed the DMA relay and jumpered connections 30 and 87B, pressurized the rail. There were no leaks, everything checked out. So I reinstalled the DMA relay and connected the injectors, and it's time to fire it up. With the injector issue resolved, the engine's firing on all cylinders, nice and smooth. When the engine reaches normal operating temperature, the temperature gauge on the dash should be just under the halfway mark, and the electric fans will kick on. At that point, you'll know that the thermostat is open and fluid is moving throughout the entire system, and we can go ahead and begin the venting process. In this case, I completed 4 venting cycles, and on the 4th one, just the tiniest bit of air came out, so the system is fully bled. Go ahead and check your fluid level at the tank and top it up as needed, but otherwise the system is now properly vented and the engine's ready for normal operation. Now that the engine has been run through a few heat cycles, I'm going to go ahead and perform a compression test. This will reveal the condition of the valves, the valve seats, the piston rings, and the head gasket on the engine and determine whether they are wearing evenly. Healthy engines should typically have a compression rate of over 100 psi per cylinder, and with no more than a 10% variation between the highest and lowest readings. The test as performed is more accurate when the engine is warm, so now that the engine is run to operating temperature, we're going to go ahead and remove the spark plugs. We're going to be turning the engine over a number of times, and we don't want it to fire, so we'll also remove the DME relay to prevent fuel from being injected into the cylinders. And we're going to crank the engine 4 to 10 times per cylinder after the tool is connected. Typically I'll just do 8, and we're going to ensure that there's a consistency in that process from cylinder to cylinder, so whichever number you pick, just repeat that same number of cycles as you go 1 through 4. There can be some disparity across different engines and different tools, and even changes in altitude can affect the reading, so you can't really say that every 944 of this particular model year should have this compression reading. But in general terms, for the naturally aspirated cars, the earlier 944s will test in the area of 140 psi, and the later models 87, 88 will test in the area of 150 psi. So let's go ahead and get the tool connected and crank it through some cycles. With the compression tester installed on each cylinder and cranking the engine 8 times with the throttle wide open, I'm getting consistent results across the board. Cylinder 1 is coming back at 144 psi, 141 for cylinder 2, 140 for cylinder 3, and 145 for cylinder 4. So seem to have resolved the issue on cylinder 4, and all the results are within 10%, which is great to see. So the results are consistent and the engine appears to be in a healthy state. Although I was expecting the total PSI values to be a little bit higher, I think it's the result of this cheap gauge from Harbor Freight. I'm not even able to use a wrench to tighten down this fitting. It's just hand tight with the hose, and this gasket is already starting to split apart. So probably time to scrap this tool, even though I've only used it 4 or 5 times, and pick up something a little bit better quality. But overall, it looks like everything is sealed up nicely and tightened to factory specifications, so should have a nice clean running engine for the foreseeable future. Now that the compression test is checked out, I went ahead and reinstalled the spark plugs, tightened to 18 foot-pounds, installed the spark plug cables and the DMA relay, and it's time to take the car out for a drive. Well, after taking the car out, everything seems to be running well, and the engine feels like it has a lot more output than before, and no leaks on the return home, so everything's checking out. As far as costs go, in adding everything up, I went ahead and split it into 3 separate categories for the cylinder head, the coolant system, and the engine bay parts refresh. For the cylinder head, it was about $550, most of which was for services at the machine shop, and some of these parts you may not need, but probably looking at least $200 or $300 for most situations in that case. The coolant system refresh wasn't really necessary. It was more for really proactive maintenance and appearance purposes. Most of that was the expansion tank and the heater pipe and various hoses. The engine bay parts refresh was strictly for restoration purposes. After the bead blasting, the powder coating, and the zinc plating, everything looks great, but that's a cost that you may not necessarily need to absorb given the situation for your car. The head gasket repair totaled $588 for all the parts, separate from the head. The gasket kit was $87, and of course, $40 for a couple gallons of coolant. The rest of this stuff is incidental, seals, washers, and different things. And finally, the exhaust manifold came in at $182 after the part, the shipping, and the blasting and the reconditioning to get it to where it needed to be. So all in, with everything that was done during this repair, came in just over $2,300. $1,000 of which, though, was basically rejuvenation items to restore the car a bit. And the head gasket repair itself came in right around $1,000. You may be able to get that down if you just go bare essentials, $500 or $600, depending on your location and the types of services you have available to you. But anyway, that closes out the head gasket repair, and it's time to go enjoy the car a little bit before moving on to the next item. Hope you enjoyed this series, and good luck with your repairs.